Welcome back. Once you have all the parts on hand, it's time to make them fly in formation as a working keyboard. If you had JLC assemble your PCB, you can sit back and relax, as everyone else deals with the surface mount parts. Otherwise, get out the microscope or jeweler's loupe because these things are tiny. I'm in awe of the people who regularly handle surface mount parts much smaller than these, but I do think even the average skilled solderer can learn to handle SOD123 diodes without too much crying. If you're brand new to soldering, check out a tutorial like this one, linked from the resource page in the description. I could teach you, but then we would both have my bad habits. We'll start with the hot swap sockets, which sit nicely in the board cutouts like this. Add solder to the little cup on each end, and it's done. This is surface mount soldering on easy mode. Once those are in, start assembling the microcontroller on its header pins. The short end of the pin will go into the PCB to provide a little space here for the C-Picro to sit on. If your header pins aren't the exact quantity needed for this board, they're designed to snap off between pins. A pair of pliers or diagonal cutters make this even easier to break in the right spot. No reason they have to all be attached together, but it does make them easier to wrangle. Now, put the microcontroller on top of the pins. This will make sure everything stays aligned while we're soldering it. And remember, we wanted our C-Picro component side down, so the USB port will be between this board and the board underneath. And no, this is not a C-Picro, this is a ProMicro RP2040, but it has the same pin out. Heat up each pin, along with the ring-shaped pad it's on, and add just enough solder to flow over the pin in a nice tent shape. You can always go back and add more later, but be careful not to overflow into the next pin. If you wind up with a bridge between pins, just reheat both of them. Your iron will pick up a little solder by itself if you clean it off each time, or you can use a solder wick to suck up the excess. With all the header pins attached to the microcontroller, use some mild tape like Scotch tape to ensure it stays in place when it's flipped. Rinse and repeat on the top side with all 31 header pins. If you didn't have JLC attach your reset switch, we can do that now. If you dab the pads with a solder flux pen, it works great to hold the part in place while you solder it, and as a bonus, the solder flows better. Finally, I think we're psyched up to tackle the diodes. Good thing we added that stripe to the diode silkscreen, because orientation is crucial here. You'll need good lighting, and maybe some magnification to find the stripe on the diodes. Dab flux on the pads, stick the diode down with some tweezers, then solder in place. You have a ton of room to work with around these pads, so there's not much that can go wrong here. Worst case scenario, clean up the solder, reposition the diode, and try again. Nuclear case scenario, you have some spare boards if you really need them. And with that, the hardest part of assembly is complete. In order to install the key switches and start testing, we'll want to put the top plate on. If you'll recall from our stack-up sketch, we'll use screws through the top plate, through spacers, and the PCB into the standoffs. If your spacers aren't cooperating for this process, use a dab of glue to hold them in the right spot on the PCB. Now we can pop the key switches in and start looking like a keyboard. Take a look at your sockets after putting the key switches in. If one wasn't soldered well enough before, it may be sticking up after inserting the switches. Push it back down and resolder it. Resolder the other side too, because you may have cracked the solder joint. Before you put the bottom plate on, we're going to check that all the solder points and component placements were good, but we'll need some firmware loaded to do that. We'll set the hardware aside for a minute. I chose VIAL firmware for this series because you can remap the keys endlessly using its web or desktop application without having to rebuild and reflash firmware. The build process is a little bit hairy, but just stick with me and we'll be fine. If you're really stuck, I'll provide a link to pre-built firmware that works with the layout we've been using in the video. I'll be showing the process on Windows 11, but if you have a Linux machine or VM handy, that works exactly the same once we finish setting up WSL, the Windows subsystem for Linux. VIAL is built on the QMK platform, so we'll set up the build environment by installing QMK WSL. Here on wsl.qmk.fm, the Getting Started guide tells us to start by installing WSL2. The Microsoft page on that tells us to start a command prompt in administrator mode. CMD, right-click, run as administrator. Yes. And run the command wsl -- install. Yes. This will download a bunch of stuff. All the commands, by the way, are on the MacroPad resource page. If you didn't catch what I typed, you can always copy and paste them. It will think for a while, download a few gigabytes, and you'll have a shiny new Linux environment running alongside your Windows 11. It wants to reboot, of course, first, so please hold. The WSL installation continues after the reboot by asking for a username and password to secure your Linux environment. Once that's done, back on the QMK WSL page, we can download the latest release and run its installer. When that finishes, we have a shiny new item in our start menu for QMK WSL, which opens the command prompt. We'll install the VIAL flavor of QMK with a git clone command. And that's here on the MacroPad resource page. You want to copy it here. Control C, right click to paste, and hit enter. As always, give that a few minutes to download. When it's done, type cd vial-qmk, then make git-submodule, and give it some time to install more requirements. Now we're ready to start telling QMK about our new keyboard. Type QMK space new dash keyboard. Every keyboard needs a name. I've been calling this one Macro 0. Anything alphanumeric with no spaces will work fine. It wants a GitHub username, unless you're actually sharing this firmware. Really doesn't matter, any username is fine. What you put in here for real name actually shows up in VIAL as the keyboard designer. Again, use whatever you want. Now we need to pick a starting layout. If you can find a layout that's close to yours, or larger than yours, that will simplify your life greatly. Our layout is basically a 4x4, 4 rows and 4 columns. So I'm going with Ortho 4x4. If yours is larger than that, I recommend an ortho layout the same size or bigger than yours in both directions. Finally, pick the RP2040 microcontroller. It says we're ready to compile, but we've got some customizing to do. You'll see the path to the files for your new keyboard here. If you open File Explorer, you'll see a new location here in the lower left labeled Linux. If you expand that, you'll see the Ubuntu installation that Windows installed and the QMK WSL installation we just installed. If you open that, you can navigate to the path shown here: Home, QMK, VIAL QMK, Keyboards. Now this is a big directory, so we'll type macro, there it is, macro 0. We'll be editing some JSON files, which you could do with Notepad, but it's easier with an editor like VS Code that can highlight it. VS Code is a little paranoid about opening the file because it's technically from a network share, so reassure it that it's allowed to open this file. We'll see some boilerplate with the fields we filled in for the new keyboard wizard. The first thing we want to check is the diode direction. For our circuit board, this should say column to row. Why is that? On our circuit board, voltage flows from the column pins through the key switch, through the diode in this direction into the row pins, so col to row. The next vitally important detail about our specific circuit board is here under matrix pins. We can refer back to our PCB layout to confirm these details. I put the column pins on GP2 through GP5, and the row pins on GP6 through GP9. Those are the names that we need to put in the config file. There's no requirement that the pins be in order or grouped together or anything like that. Any GPIO pin you use is fine. If you didn't label your PCB pads when you connected them up, pull up the cPICRO pinout reference again to get the GP pin numbers. Remember that the KiCad footprint numbers are not the same thing. Here's that pinout. So pin 2 would be referred to as GP2 in this file. Our columns are GP2, GP3, GP4, GP5, and rows 6, 7, 8, 9. If you picked a base layout with more rows and columns than your MacroPad, QMK is going to complain if you don't define the same number of pins here. You can see the base layout that you started with here. If your layout is smaller, fill out the pins you aren't using with no underscore pin, like this. So if I picked the 4x4 layout, but I'm building a 4x3, this row pin doesn't exist. So it might look like this. We don't actually care what QMK thinks our keyboard layout or key map are, as long as it's willing to compile without errors. Our actual key mapping will be done in VIAL. Save your keyboard.json file, then back at the command prompt, type QMK space compile space -kb macro 0 -km default. Here for reference. If everything is happy with the keyboard.json file, it'll end with a copying UF2 to QMK firmware folder line. If you didn't give enough matrix pins for the key map that's configured, it'll look like this. Check your matrix pins definitions. All right, QMK built a UF2 firmware file, which is ready to flash on our controller. If you're happy editing your layout and recompiling and reflashing to make changes, you're done here. If you want to remap keys on the fly using VIAL, though, we have a few more steps to go. Remember Keyboard Layout Editor? We'll use it to give VIAL information about the row and column we connected for each key switch. keyboard-layout-editor.com. Hopefully you saved your layout and can load it here, but if not, go ahead and recreate it. Precise positioning is not essential anymore. This is the diagram that will be shown in the VIAL application when you go to remap keys. If you have any legends on your keycaps, go here to Tools, Remove Legends, All. As long as you have no keys selected or all keys selected, that'll remove all the existing legends. Back here under Properties, for each key, we need a top left legend with the row number and column number that key is connected on. Top left is going to be 0, 0, and then we'll move across row 0, column 1 for each of the keys. If your keys are a complete matrix, this will be very straightforward and very boring. If your keys are not a complete matrix, though, this is where we tell VIAL exactly where each key is connected. So for example, in our bottom row, it's not immediately obvious unless we go back to our PCB reference, where we can see that our first switch is actually in column 1, not column 0. And column 1 goes this way, column 2, column 3. If we had told VIAL that this switch was connected to column 0, it would happily look for it there, and it would never see a key press. So pay careful attention to the row and column numbers here. All right, all our keycaps have legends. We'll go over to the Raw Data tab, select all, and copy. We need to turn this into a JSON file that VIAL understands. I have a template file linked from the resource page for you to start with, vial.json. You can download and edit that. You can change the number of rows and columns here if you need to. Our keyboard is 4x4. Select this line and paste the raw data from KLE. Unfortunately, KLE uses JSON 5, which allows these unquoted properties, and VIAL does not. So we need to go in and add double quotes around each of these W values. If that's going to be especially tedious for your layout, or if you're not sure how to do that, you can also Google for a JSON 5 to JSON converter online. So json-5.com, for example, you can paste your raw data in. It also wants a set of square brackets around it. And then it will happily give you a correctly formatted JSON file with the properties quoted. So again, that goes in the key map section of the vial.json file. We'll save it, and now we'll test to see if VIAL understands it. We need to install the VIAL desktop app. You can get that from the download links here. There's also a web version at vial.rocks, but it doesn't support the one feature that we need right now, which is testing a dummy layout file. Open the app and go to File, Load, Dummy JSON. Find the file we just saved, file.json, and make sure it loads with no syntax errors and shows the layout that you expect here on the screen. This is what you use to actually map the keys once we have it programmed on the keyboard. Right now this app doesn't do anything else for us, so we'll go and close it out. Hang on to that vial.json file for the next step. In Windows Explorer, find your keyboard folder again. That's under Linux, QMK, Home, QMK, VIAL QMK, Keyboards, and Macro 0, whatever name you gave it. In here, there's a keymaps folder. Go into that, select the default folder and make a copy of it. Control-C, Control-V. F2 to rename it. This key map has to be named VIAL, all lowercase. Remember, Linux is case sensitive, so be sure it's lowercase. The vial.json file we created earlier goes in this directory, and we need a file named rules.mk. You can get that from the resource page. And the contents of this file are like so. VIA enable equals yes, VIAL enable equals yes, VIAL insecure equals yes. Wait, insecure? Yes, since VIAL is easily reprogrammed, some people worry about malicious websites or apps trying to hack their keyboard, so they want a secure way to enable reprogramming. Personally, I think that's unlikely, and any website that wants to talk to my keyboard is going to pop up an authentication prompt first, so to each their own. Finally, we need a unique ID for our keyboard. In the QMK WSL prompt, type python3 util/vial_generate_keyboard uid.py. Again, that command is on the resource page if you want to copy it. You should get a pound-defined line like this one that you can copy to the clipboard, select it, enter, and paste into a new file in the keymaps VIAL directory called config.h. Once you have those three files added to the VIAL directory, vial.json, rules.mk, and config.h, we're finally ready to compile. We'll do qmk compile -kb macro 0 -km, that's keymap, VIAL. If all goes well, it will soon be copying macro 0 vial.uf2 to our QMK firmware folder, which is actually right where we are. Home, QMK, VIAL QMK. Hardest part done. If you weren't able to follow along to build the firmware, there is a link to the pre-built firmware on the resource page for this exact layout. And the file that we want to flash is now here in Linux QMK Home, QMK, VIAL QMK. If you haven't been able to resist connecting your newly assembled keyboard to your PC, you may have noticed that it mounts a new USB drive when connected. This is the beautiful thing about the RP2040 bootloader. No special tools needed to flash it. All we need to do is find the macro 0 vial.uf2 file we just built and drag it into the RP2040 drive like this. It reboots itself and comes up running the new firmware, and without a USB drive mounted. If you need to reflash it for any reason, you'll need to use the reset button to get back to the bootloader the second time. For the cPICRO, hold reset for at least half a second and release, and you should see the USB drive connect again. Now we find out how the soldering process went. Fire up the VIAL desktop app or vial.rocks in a browser, and you should see your shiny new MacroPad pop up. If not, make sure you program the firmware with the UF2 file. Click over to the Matrix Tester tab and test out the key switches. If they're lighting up in the wrong position, you probably have a configuration issue with your row and column pins, or the key switch legends we set up in KLE. If one or more switches aren't lighting up, it could be configuration, like the wrong column number for a key, or it could be the circuit board. Make a note of which ones aren't working. The screen will disappear when you disconnect the USB. Then, back to the soldering bench. You may have overlooked a solder point entirely, or it may be a cold solder joint where it looks good but doesn't actually make contact. Or if your eyesight is like mine, you may have swapped a diode end for end. Double check everything, and hopefully it's an easy fix. Try a different key switch in that spot, and make sure the pins aren't bent. Once all our key switches are lighting up in the right spots, we're ready to start mapping them. Click over to the Key Maps tab, click a switch in your layout, then click what you want it to do in the bottom section. Just like that, it's mapped, even after you close VIAL, or plug it into a different PC. You'll find less common keys on the App, Media, and Mouse tab, including F13 through F24, media keys, mouse keys, and more. You can even assign keys to macros and program them inside VIAL. Now that everything's working, we can put the bottom plate and walls on. Congratulations, that was quite a project, and you probably have some ideas for things to do differently next time. But great work getting the first one out of the way. And thanks for sticking with me for this epic-length video series. As you brainstorm your next project, think about the possibilities with RGB lighting, encoders, screens, and wireless. Good luck, have fun.